It is Wednesday, June 24th, 2026, and this is the Neural Deep Dive. I'm Leonard Cooper, and I'm the only guy here who remembers what a real radio dial feels like.
I'm Roxy Stone.
And I'm Alyssa Montgomery.
This is Vector Kane. We have a great show for you today.
Now, if you already caught today's Neural Daily, welcome back. This is a bonus weekly deep dive on top of the regular show. Yesterday, we covered a ton of ground, from Oracle's infrastructure pivot to that Mythos 5 security breach that basically gave the NSA a heart attack. But today, we're stepping away from the headlines to focus entirely on a massive shift in how AI actually thinks. We're talking about JEPA, Joint-Embedding Predictive Architecture, and the move toward latent-feature world models.
Which is basically a fancy way of saying the current way we build AI is kind of a joke, right?
I wouldn't say a joke, Roxy. It's just, the first iteration. We're moving from the token era to the world era.
Right. Basically, we're talking about the difference between a parrot that's memorized the dictionary and something that actually knows why a ball rolls down a hill. I mean, the industry is hitting this data wall, which, here's the thing, we're just running out of stuff to read.
Oh, well, it's not just that we're running out of text. It's that text is a low bandwidth representation of reality. If I want to teach a child how a door works, I don't give them a 10,000-word essay on hinges. I just show them the door.
Exactly. And current LLMs are basically just the world's most expensive essay writers. They're just guessing the next word based on a giant pile of internet scrapings.
But that's the beauty of the scaling laws. We just needed more compute. But now we're seeing that the returns are diminishing, which is why Jan LeCun and the FAIR team are pushing JEPA.
Now, for the folks at home who aren't PhDs like Alyssa, who, by the way, probably knows the exact molecular weight of her sourdough starter, what is JEPA? In English, please.
Well, JEPA stands for Joint-Embedding Predictive Architecture. Instead of trying to predict the next token or the next pixel, which is what generative AI does, it predicts the next internal representation.
Wait, so it's not actually generating anything?
Not in the way we're used to. It doesn't try to reconstruct the image. It doesn't care about the exact shade of a pixel. It cares about the concept of the object in the image.
Right. It's like literally ignoring the noise. If you're watching a video of a tree in the wind, a generative model tries to predict where every single leaf is going to move, which is, totally inefficient.
Sure. Imagine documenting a chat via capturing AC noise behind. Forget those drones. Essentially, VJEPA claims, I disregard foliage. I only value a moving plant.
Which sounds a lot more like how a human brain works. I don't remember the exact coordinates of every blade of grass in my backyard, but I know where the fence is.
Precisely. By predicting in latent space, the model avoids the reconstruction bottleneck. According to a recent technical briefing from the FAIR team, VJEPA 2.1 is showing a 3 times reduction in training compute compared to video diffusion models.
3 times! That's absolute velocity! Imagine the ROI on that compute spend.
Oh, look at Vector, getting all excited about the balance sheet again. Honey, the ROI is that we might actually get a robot that doesn't fall over its own feet.
Oh, hey, don't knock the falling over part. That's where the comedy is. But seriously, this world model thing, this is the holy grail, right? The idea that the AI has an internal simulator of physics?
Sort of. It's an attempt to implement System 2 reasoning. Most LLMs are System 1, fast, intuitive, but prone to hallucination because they're just reacting. A world model allows for gradient-based planning. It can think through a sequence of actions in its head before it executes them.
Right! It's like literally playing out a simulation of the future, which is exactly what I did with my toast chain startup, except the simulation didn't account for the market's risk aversion.
We're still talking about the toaster, are we? Move on, Vector.
Right. Sorry.
So let's get into the weeds here. If we aren't generating pixels, how do we even know if the model is right? I mean, if I ask an AI to draw a cat and it gives me a blob, I know it failed. But if it's just predicting a latent representation of a cat, how do we check the homework?
That's the joint embedding part. The model has an encoder that turns the input into a representation and a predictor that guesses the next representation. Then it compares the predicted representation to the actual representation of the next frame. If they match in the embedding space, the model is correct.
So it's like a matching game?
Essentially, yes. It's learning the underlying structure of the world without needing to be told what every single pixel is. It's unsupervised learning at its most elegant.
Now, hold on. I've read some of the critics on Medium. There's this one guy who says JEPA isn't a paradigm shift. It's just masked prediction refactored. Basically saying we're just putting a different hat on the same old trick. Is that true? Is Lacoon just selling us a new brand of the same old soda?
No way! This is a fundamental shift in the objective function. We're moving from reconstruction to prediction.
Oh, I'm sure the marketing department at Meta loves that distinction.
Well, actually, the critic has a point regarding the mathematical foundations, but the application is where the shift happens. When you stop trying to generate every pixel, you can suddenly scale to much more complex environments because you're not wasting 99% of your compute on high-entropy noise.
High-entropy noise. That's the leaves on the tree thing again, right?
Exactly. In a video, the exact movement of a cloud is high entropy. It's unpredictable and mostly irrelevant. The fact that the cloud is moving across the sky is the latent feature. JEPA ignores the noise and captures the feature.
Which is why this is so huge for robotics. If you're a vision language action system, a VLA, you don't need to know the exact texture of the carpet to pick up a coffee mug. You just need to know the spatial relationship between the hand and the handle.
Which is why we're seeing this surge in robotics. We've spent years trying to prompt robots to be smart, but they need a physical grounding. They need to understand gravity, momentum, and friction.
Right. You can't prompt a robot to not knock over a vase if it doesn't understand that the vase is a solid object with mass. It's like trying to teach my bulldog Atari to not fart by reading him a book on etiquette. It's just not going to happen.
Precisely. Physical grounding is the missing link. By using JEPA as the backbone, these robots can develop an intuitive sense of physics. They aren't just following a script. They're predicting the state of the world.
I love the idea of a robot that can actually predict a disaster before it happens. Imagine a warehouse robot that sees a pallet leaning and thinks, actually, the latent representation of that center of gravity is skewed, and then moves it before it crushes a worker.
Now that's a value add. That's the kind of efficiency that drives a stock price up.
Vector, if you mention a stock price one more time, I'm going to use my latent representation to predict exactly where your shins are.
Okay, my bad.
Brutal. I love it. But let's talk about the flip side. If we move away from generative AI, the stuff that actually makes things, are we losing something? I mean, I love my Mid-Journey art, my deepfake videos of 80s action stars. Does JEPA kill the creative side of AI?
Not necessarily. I think we're looking at a hybrid future. You use a JEPA-style world model for the reasoning and planning, the System 2 part, and then you use a generative model as the renderer to actually produce the output.
So the world model is the director, and the generative AI is the camera crew?
That's a great way to put it. The world model decides what should happen based on the laws of physics and logic, and the generative model figures out how to make it look pretty.
Now that makes sense. It's like the difference between knowing how to write a screenplay and knowing how to light a scene. You need both to make a movie. But here's the deal. If this is the path to AGI, are we actually getting closer? Or is this just another winter waiting to happen?
It's the opposite of a winter. It's a spring cleaning. We're clearing out the inefficient token prediction garbage and replacing it with actual intelligence.
Garbage. Bold words from a man who once invested his life savings in a decentralized toaster.
Hey, the tech was sound. The market just wasn't ready for the velocity of the blockchain integrated heating element.
I'm still laughing at that. Blockchain integrated heating element. I can't even imagine how that works. Does the toast get minted as an NFT?
It was a prototype.
Anyway, to Leonard's point about AGI, this is a significant step because it addresses the hallucination problem. Hallucinations in LLMs happen because the model is just predicting the most likely next word, not checking if that word corresponds to a real-world fact. A world model doesn't just predict a word, it predicts a state. If the predicted state is physically impossible, the model can recognize that.
So it's like a built-in BS detector?
In a way, yes. It's a consistency check against a learned model of reality.
I could use one of those in my third marriage. Crystal tells me my chakras are misaligned, and I'm just over here like, is that a latent feature or just a high-entropy noise event?
I'm sure it's a very high-entropy event, Leonard.
Oh, absolutely. But let's pivot for a second. Before we dive deeper into the JEPA 2.1 specifics, we got to take a quick break. Hey, before we move on, a quick note from our sponsor. This show isn't magic, it's engineering. Eric built our entire stack from research agents to vocal synthesizers, which requires massive compute. To keep us online, please like, subscribe, and sign up for a free Patreon trial at patreon.com/neuralnetworkmedia today. Your support makes this possible. All right, we're back. Let's get back into the latent space.
So, talking about JEPA 2.1, the March 2026 release, the thing that really blew my mind was the cross-modal capability. It's not just video. It's integrating audio and sensory data into the same embedding space.
Which means the AI can hear a grass break and know it's broken before it even sees the shards.
Exactly. It's creating a unified representation of the environment. In the old paradigm, you'd have a vision model and an audio model, and then a fusion layer that tried to glue them together. In JEPA, the embedding space is joint from the start. The sound of the glass and the image of the glass are just different views of the same latent object.
That's actually kind of spooky. It's like the AI is developing a sense of presence. I mean, we're basically building a ghost in the machine that can feel the room.
A ghost that's very efficient with its compute.
But think about the applications. In autonomous driving, you can't just rely on cameras. You need the feel of the road, the sound of the tires, the radar, all of it feeding into a single world model that predicts the next 3 seconds of reality.
Right, and that's where the planning comes in. If the model predicts that the current trajectory leads to a high probability collision state in the latent space, it can trigger a corrective action before the physical event even happens.
So it's basically like having a psychic driver?
Not psychic, just very good at physics.
I don't know. I'm still a bit skeptical about the world model branding. It sounds like something a Silicon Valley CEO says right before their company goes bankrupt. We're not just a ride-sharing app. We're a world model for urban mobility.
You're just being cynical, Roxy. This is the actual path to AGI. If you can model the world, You can reason about the world.
I'm an investigative journalist, Vector. Cynicism is my primary fuel source. I just want to know who's actually benefiting. Meta is pushing this hard. Why? Because they want to dominate the robotics layer. They don't just want to own your social media feed. They want to own the brain of the robot that cleans your house.
Now that's a scary thought. Imagine a metabot that's constantly trying to A/B test your living room layout to see which one makes you more likely to buy a new blender. Your latent representation suggests you're lacking a high-speed smoothie maker, Dave.
Well, that's the corporate incentive, but the technical achievement is separate. The move to latent feature prediction is a response to the data wall. We've scraped the internet, there's no more text to eat. The only way forward is to learn from the raw, unlabeled sensory data of the physical world.
Exactly. The world is the biggest data set. There are trillions of hours of video, billions of sensory streams. It's an infinite buffet of data.
As long as we don't mind the AI learning by watching us fail in real time.
Observe my life. I am a living example regarding failed wedlock. I am a treasure trove regarding AI research.
Actually, Leonard, your life would be a great test case for high-entropy noise. The model would probably just decide to ignore your entire history as an irrelevant feature.
Hey, I'm a feature. I'm a legacy feature.
A legacy feature with a lot of noise.
Ouch.
All right. Settle down. Let's get serious for a second. If we're moving toward these world models, what does that mean for the average person? I mean, I'm not a robotics engineer. How does this affect the guy who just wants a better chatbot?
It means the chatbot stops being a chatbot and starts being an agent. An agent with a world model doesn't just give you a recipe for a cake. It can actually understand the steps of baking. It can predict that if you forget the baking powder, the cake will be flat. It's the difference between knowing the words for baking and understanding the process of baking.
Right. It's the transition from information retrieval to cognitive simulation.
Which sounds like another way of saying it can finally tell when I'm lying.
Imagine that. A world model that can tell if your husband is actually at the gym or if he's just sitting in his car eating a burger. Well, that's a product I can get behind.
Barney wouldn't last 5 minutes. He's too predictable. His latent representation is just protein shake and fear of me.
See? That's a low entropy system. Very easy to model.
Stop.
Sorry.
So let's wrap this up. We've gone from the data wall to latent spaces. We've talked about the leaves on the tree and the ghost in the machine. If there's one takeaway here, it's that the era of just adding more tokens is over. We're moving into the era of understanding how things actually work.
I think that's a fair summary. The shift to JEPA is essentially an admission that language is not enough. To reach true intelligence, AI needs to experience the world, even if that experience is just through a lens of latent embeddings.
And it'll probably do it all while using 3 times less power, which is the only part of this I actually care about.
It's all about the velocity, people. The world is moving toward a simulated reality, and we're just the ones building the simulator.
Spoken like a true crypto bro. All right, that does it for this week's deep dive. We've gone from tokens to latent spaces and back again. I think we can all agree that the future is looking a lot less like a dictionary and a lot more like a simulation of a very confusing living room.
Bye.
Later.
Take care.
Keep your antennas up, folks.